this is how you would do the ray diagram for the flat mirror. Okay, the first two rays are the easy ones. You're just gonna go straight into the mirror and straight out. So the trick here is to make it perfectly perpendicular. Straight in, straight out, and then dotted behind. Okay, then you're gonna do it again from the bottom. Straight in, straight out. Okay, double arrows showing it's going in and out, and then dotted behind the mirror, because those are fake light rays. They don't really exist. Okay, then we're going to pick a ray, any ray. So it doesn't matter which one you do. Just go from the bottom and just take a ray and make it hit the mirror. And then you're going to line up your protractor. Okay, so this protractor, I'm going to line up this T with where it hit the mirror, and I'm going to line up this line here with the mirror. And then I'm going to mark 90 degrees. Okay, so this angle is 10, 20, about 20.5 degrees, because I can estimate in between the lines. So I'm going to go 20.5 on the other side. 10, 20, 20.5. And I'm going to label those angles with their measurement to show that, hey, I measured it and they were straight. So the 90 degrees is my normal. So I'm going to make that dotted. It's a reference point. So it's not like a real light rate. So this is my normal. And then I'm going to draw in the reflected ray and go dotted behind. And since both of those light rays originated at the bottom of the object, where they meet up, that is the bottom of the object or the image. So we're going to do the same thing from the top. Pick a ray, any ray. So notice I didn't care which angle it was. I just, from the top, hit the mirror, and then do the same with my protractor. Line it up. Okay, so the T is hitting where it hit, and the line is lined up with the edge of the mirror. Mark my normal, 90 degrees, and this one is 10, 11, 12, 13 degrees. So I'm going to go 13 degrees on the other side. 10, 11, 12, 13 degrees. And I'm going to draw in my normal. I'm going to draw in my reflected ray. Label them both 13 degrees because I measured them. Then I'm going to bring my reflected ray, so it's always the reflected ray that comes back behind the mirror, only that one. And that's the top of my image because both of them originated at the top of the object. Et voila, there's my image. And I know that I'm right because if I measure this distance, that's 4.4 centimeters, and that is 4.5 centimeters. So that's close enough, okay? This distance here should equal this distance here, and this height here should equal that height there when you are done. So it's hard to see what you did when you're done, but follow the process. 2 rays from the top, 2 from the bottom. Okay, you're going to go straight in, straight out from the top and the bottom. And then you're going to choose a ray and the angle of incidence is going to equal your angle of reflection. Your angle of incidence that it comes in equals your angle of reflection that it bounces out. So you should have 4 rays when you're done. You should have 2 with equal angles, and you should have 2 that go straight in, straight out, and then dotted behind the mirror because this is a virtual image because it's in the mirror.